water cooler. The objective is children can build a simple and cooler with teacher guidance, and then children understand the basic idea of cooling using ice and a fan. Okay, and then the important is children learn science in a fun and easy way. Number 2 is the project use safe and simple materials.
Our project started with a discussion about the hot winter and how people usually use fans or air conditioner. We asked questions like why does a fan make us feel cooler and what happens when air passes through ice. We compare normal fan air with air that pass near ice and realize that combining both can produce cooler air. Then we brainstormed materials such as recycled bottles, mini fans, batteries, and switches, and sketched simple design. By the end of the phase, we agreed to build a mini air cooler using recycled materials and test if it produces cooler air than a normal fan. This inquiry encouraged curiosity, teamwork, and creative problem solving.
First, prepare the container. Begin by selecting a clean and sturdy plastic jar with a lid that can be sealed tightly. Now, it's time to connect the wire. Take the red wire from the motor and connect it to one side of a DC switch. Connect the other side of the switch to the red wire of 9-volt battery. Number 2. Attach the DC motor. Make sure the motor stands firmly and does not wobble when touched. Number 3. Install the fan blade. Push it gently but firmly until it locks in place. After fixing it, spin the fan blade lightly with your finger to test if it rotates freely without touching the lid.
Betul ni. Alhamdulillah.
Sebab kat sini pun dia buat saya ni. Kat sini pun dia buat saya ni.
Project description. This project is a mini air cooling system that uses ice as the main cooling medium and a small fan as the airflow mechanism. Outside air is drawn in channel through the ice-filled compartment and then pushed out in a cooler state. The design is suitable for basic science learning purposes, such as understanding the concept of cooling, air circulation, and heat transfer, and can also serve as a simple example of a ventilation system in daily life. This project makes use of recycled material.
So the reflection is through the Equally project, I was able to acquire and strengthen a wide range of skills that are valuable both academic and in real life. From a cognitive perspective, I learned how to connect scientific knowledge with practical application. At the same time, I developed creativity and innovation skills by thinking about how recycled materials could be transformed into something useful. This pushed me to think outside the box and find alternative solutions to everyday problems, such as how to stay cool without relying too much on an air conditioner. The learning process throughout this project was meaningful because it combined both theory and practice. At the beginning, I reflected on my prior knowledge, such as my experiences of using a fan or an air conditioner at home and understanding that ice is naturally cold. Finally, this project also raised my awareness about the importance of energy saving and environmental sustainability. I realized that by reusing and recycling simple materials, we can reduce waste and create tools that are not only affordable but also environmentally friendly. That's all. For the improvement suggestion, while the Equally project was meaningful and beneficial, there are many ways it could be further improved to make it more efficient, practical, and sustainable. One of the main challenges of the project was the cooling effect did not last long because it relied only on ice, which melts quickly. To address this limitation, a possible improvement would be to replace ice with phase change. To address this limitation, a possible improvement would be to replace ice with phase change material or reusable cooling fans. In addition to improving cooling performance, the project could also become more environmentally friendly by using renewable energy sources instead of depending on disposable batteries, which can be costly and harmful to the environment. The cooler could be powered by small solar panels. Apart from technical improvement, there are also ways to enhance the educational experience. Since some students may struggle with assembling and testing the device, teachers could provide a detailed step-by-step guide or organize a short demonstration before the project begins. Another suggestion is to integrate digital elements into the project. For example, students could use simple temperature sensors or mobile applications to measure or compare the effectiveness of their air cooler before and after improvement.
This project is a mini air cooling system that uses ice as the main cooling medium and a small fan as the airflow mechanism. Outside air is drawn in channel through the ice-filled compartment and then pushed out in a cooler state. The design is suitable for basic science learning purposes, such as understanding the concept of cooling, air circulation, and heat transfer, and can also serve as a simple example of a ventilation system in daily life. This project makes use of recycled material.
simple materials, we can reduce waste and create tools that are not only affordable but also environmentally friendly. That's all.